Specifically, what that is they are sharing the same center. So put the little center right here. And then if they are both sharing this center, they are called co-centric. Like co-teachers, Mr. Krubitz and I we both do it. They both share that same center. Okay. So that's concentric circles. The center is the same for both of them. You have a co-worker, all right, you share your jobs. All right. In this case, they share the center. All right, we can have congruent circles. Those are circles whose radii are the same. So if I put a dot in here and I tell you that this has a radius of 6 and then this has a radius of 6, then we know those are congruent circles. Much like congruent triangles, they're the exact same thing, two separate ones. All right, all that's pretty simple. Now we get into all these weird things that are probably new to most of us here. The first one is the word chord. A chord is a segment. So we've talked about a segment. A segment is a line that has a distinct starting and end point. Those endpoints are on the circle. So if I put a dot right here, and if I put a dot right here, if I connect those to make a segment, so that satisfies this idea that it is a segment. If those two endpoints are on the circle, this is a chord. So you can obviously have a whole bunch of chords. If I drew one in right here, that's another chord. As long as the two endpoints of the segment are on the circle, is what we call a chord of the circle. Okay. All right, the next two, a secant line versus a tangent line. So now obviously there's going to be a line that intersects a circle at 2 points. So if I draw in a line and it's going to intersect the circle once here, and then that line continues on, it's going to connect the circle right there. That line there is what we would call a secant line because it intersects it at 2 separate places. Okay. A tangent line, this guy intersects the circle at exactly 1 point. So put a dot on the circle anywhere you want it. So anywhere you want, put a dot on your circle. Okay, don't wait for me to do it. So just put a dot on there. And I'm going to put it where I don't think you put it. I'm going to put it right here. And then a tangent line now is instead of hitting it at 2 different places, it only hits it at the 1 dot that you just put on your circle. So for me, mine's going to do this right here. And that's what we kind of have right here. A tangent skates along the edge of the circle, but it does never cross into the circle. So if I put one at the bottom of the circle, this would be a tangent line. It barely touches it at that one spot. So there's a whole bunch of tangent lines we could draw in if we wanted to, but those are tangents. So secants, you're going to intersect twice. A tangent line, you're going to intersect once without ever entering the circle. All right. All right, these two we should know. Radius and diameter, you certainly have talked about. A radius is, again, a line segment with one endpoint at the center. So put a dot at the center. The other endpoint is on the circle. So put a dot on the circle someplace. I'll put my dot, I'll put it down here. And when you connect the center of the circle to one of the dots on the circle, that is your radius. All right, that you should be familiar with. Next one you should be familiar with. It is a chord. Remember what a chord was? A chord is a segment whose 2 endpoints lie on the circle. A diameter is a little bit more specific because it also needs to pass through the center of the circle. So we would put an endpoint here, an endpoint here. So that's why it is still a chord. But if the chord goes through the center of the circle, then that is your diameter. And then the thing that you've seen this many times, if my radius is a 4, the diameter is the whole thing. So the diameter would be an 8. Okay, the radius is always half of your diameter. Okay, so those two we should be pretty familiar with. All right, these, a little different than you've probably seen. This now is arc. We have 2 of them. We have a minor arc, and then we have a major arc. So obviously that relates to the idea of a smaller one versus a bigger one. So the minor arc is obviously your smaller one. It is less than halfway around the circle. So put a dot in here. Don't draw in this whole thing that I'm going to draw in right now, but this is around the circle. If I want a minor arc, I want one of those that's only less than half. So if I drew in something like this, Do we agree that goes less than halfway around the circle? Yeah, that's a minor arc. It's less than half around that circle. Versus a major arc, an arc that is more than halfway around the circle. So now if I kind of started that same area, but now I extend this to where it is clearly more than half. Okay, it looks like a person now that I shaded it kind of like this. All right, that is clearly more than half. That is what you would call a major arc, more than halfway around the edge of that circle. So minor arc, less than half. Major arc is more than half. We then have what we call a semicircle, which you should know, that is exactly half. So this is halfway around the circle. So as best you can, let's say this is half here, this is half here. And if I now go halfway around to one dot to the other dot, this is a semicircle. All right. So we have less than half, more than half, exactly half. Okay, last three. A central angle is an angle whose vertex is at the center of the circle. So put a dot at the center of the circle. And what we now want to do is create an angle at that point. So the way I would create an angle is by drawing out a radius to one part of the circle, drawing another little ray or radius out to another edge of the circle. This is a central angle. So here is your angle right here that we just created. So that's an angle, and isn't it at the center of the circle? That's why it's called a central angle. Okay. We also have what is called an inscribed angle. So what this now is, it's an angle. Understand how this is different. In the central angle, the angle is at the center of the circle. Here, your angle's vertex is on the circle. So put a dot anywhere on your circle. So put a dot anywhere on here. Doesn't matter where. Again, I'm going to put mine where I'm going to guess people aren't going to put theirs, so we understand it doesn't have to go in one particular spot. I'm going to put mine right here. And then what you're just now going to do is draw two chords. So I'm going to draw one chord out to this spot on the circle. I'm going to draw another chord to somewhere else on the circle. By doing that, didn't I just create an angle right here? Okay. So the angle who's created with the vertex on the circle is what we call an inscribed angle. All right. And the last of our day of definitions is what we call an intercepted arc. It's the portion of the circle that lies between the two lines, rays, or segment that intersect our circle. So a lot of ways you can do this. Draw in a central angle for one. So draw this in. That's a central angle. That's what we just drew up here. If that's the case, this is your intercepted arc. That's the arc that's created by that angle. If I drew in, let's draw an inscribed circle. So I'll draw it in right here. So I'm going to draw in a chord to this point and this point. So this is an inscribed angle. Notice where it intersects the circle. So this would be our intercepted arc right there. All right. So a lot of definitions, and really that's all we're going to do here in a second. The little assignment that I have prepared for you to do is also just understanding all of these things. Go to the next page, and then we'll try to use some of those definitions and just name this. All right, so for the first one, it says use that diagram to answer all of these questions. So number one, it says name the center of the smaller circle. So if you find the smaller circle, look and see what the center of that circle would be. And the center of a circle always 100% of the time is a point. So we're going to write this as point. And then what point is the center of the smaller circle? And Julia, what is it? Good. So you would say point A is the center of the smaller circle. All right. Same thing in number two. You look at that big circle. So now we're looking at the big circle. We want the center of the larger circle. The center of a circle is always one point, and then we just need to identify what that point would be. All right. And Joe M., what is the center of that larger circle? So if we look at this big circle here, what point is in the very middle of that big circle? Good. It is point A again. I like that he used the word again, because when you now go to number three, we talk now, both small and large circles share the same center. So we had a word on the front page that talked about when they share the same exact center. All right, and that was, if we go back, this guy right here. Concentric circles share the same center. So that's what you were putting down for number 3. So these are concentric, concentric circles. All right, they share that same center. All right, 4. Name the radius, or name a radius of the smaller circle. So look at your smaller circle. You've talked about radius of circles plenty over in your life, I'm pretty sure. Find a radius of the smaller circle. As a hint, there are 3 of them. So you would have the possibility of 3 different answers here. Think about what a radius is. We want the radius for the smaller circle. Nothing else, just draw it in. Just highlight the one that's already in there, and then we just want to be able to name it. So the naming might be the trickier part. All right. On the front page, we said the radius starts at the center and goes out to a point on the circle. All right, so that's a radius. We're going to define it. So if we go to our smaller circle, you really have 3 different options here. So again, you can highlight these. I'll hide all of them. One radius would go from this point to this point. So that is one of the radii that you could have drawn in right there. Notice how it's a segment. So this brings back something we did at the beginning of January, a long time ago, naming segments and rays and lines. That is, you're going to go AC, and then since it is a segment, we put the little segment symbol on top of it. All right. However, isn't this right here also a radius? So we also could have put segment AD. And I didn't necessarily ask you to do all those, just to make sure we understood all of these are options. That is the radius of the smaller circle. And then we would have one more right here. Segment AB is also a radius of that circle. Okay? So any of those 3 are fine. All right, so with that, name a radius of the larger circle. So now find the larger circle, write the radius of the larger circle. Okay? What is it? Not quite. I like the I part. What's the other part, Mo? Yeah, because we want this whole thing here from the center out to the edge here. So I is the outer edge, but it has to start at the center. So IA or AI would be the radius of the bigger one. There is no other option for that one. There's only one radius for the big circle. Okay. Okay, 6. Do that. That should be an easy one. All right, here is our small circle. I want you to name a point that's, when it says on the interior, basically inside that circle. All right, so Jada, what is the only point inside of the small circle, Jada? Point what? Number 6. I'll come back to you for the next one. Okay, Jada. Sarah. Yeah, A is the only point that's inside the small circle. See this guy right here, Jada? Is that inside of our blue one? No, but I'm going to come back to you for the next one, Jada. So the only point we can put right here is point A. Actually, I won't come back to you for that one. I will, because you're going to get this one right anyway, Jada. I'll give you a few seconds to think about it. Now we want a point that is in the exterior region of both circles. So look at both circles. We want to be outside of both circles. There you go. So that has to be point H. That is the one that's in the exterior region outside of those circles. All right. All right. This is the one I was thinking of, Jada. So you just might do all three in a row here. So this one now, name a point that is in the exterior region of the smaller circle, but in the interior region of the larger circle. Now we're good. Yeah, that's our G. All right, so that is point G. G is outside of the blue little circle, but it's still inside of that bigger circle. Okay. All right, 9. Name a chord. See if you can do that. Look at the definition of a chord from the front page. There are 2 chords that you can name. So you have 2 different options here. All right, Omar, you put your pencil down quickly. What'd you get? What'd you pick? Good. So EF for sure. So, and you're going to write that as a segment. E to F. That is a segment that starts on one part of the circle, finishes on a different part of the circle. That's the one that I hoped everybody would get. And then the other one that I really want to make sure we understood, he got as well, segment BC, because it starts here, it ends there. BC is also the what, though? What would we call that? Do you know that? Anybody know what BC would also be called? It is a chord for sure. So these are definitely correct. Mo? Yeah, it's your diameter because it's a chord that goes through the center of the circle. All right, so good. So either one of those is fine. All right, so 10, when it says name a diameter, if we understood that, then we can do BC right away. That was the diameter of that smaller circle. Okay. All right, 11, answer that question. What is the length of the diameter of the smaller circle? So you got to think a little bit. Don't overthink it. All right, Assad, confident Assad? Good. You should get 16. What was your thought process there, Assad?
From D to A, which is about half the circles of 8.
Good. So we said from right here, D to A, he went to this radius right here. He knew that was 8. All right, continue.
So I think that there has to be another 8.
Good. If that's our radius, and if he did extend that on, so he didn't even really use the diameter we just talked about right here. He just knew if the radius here was 8, the other side of that point, if we drew the radius, it had to be 8. So that has to be 16 total. Okay. So isn't BC also going to be 16? Even though we didn't reference it, every diameter would be the same. All right, good. So that's got to be 16. All right, find the length of the diameter of the larger circle. So now go to the bigger circle. And we want that full diameter for the big one. So. All right, and Matt. What do you think, Matt? Good. How'd you get that, Matt?
I did 16 plus 6.
16 plus 6. Now where'd the 16 and 6 come? Oh, I get it. All right. So he understood that, I think. This was 8, kind of what Assad just said, and this was 8. And then that wasn't the big circle. He then understood there's an extra 3 right here. And then there was an extra 3 right here. So he took this 8 and 8 to get 16. He added the extra 3 to fill in the gaps on each end. So 16 and 6 should be the 22. All right, so that is correct. All right, good. Next one. All right, so this now, when it says what kind of arc is ED? So find E to D. So this is the arc symbol. So the first time we've seen this, it's a little, it actually is an arc above that symbol right there. So whenever you see that, that's implying that it is an arc. So that is, you're on the circle there. So find the points E to D. So here is E, here is D. When it says it's arc ED, it's talking about this length right here. This is the arc drawn from E to D. All right, and then we just want to name that. So we had a few different arcs on the front page. All right, Sarah, you can give me this one. Good. That is a minor arc. Why is it a minor arc, Sarah? Good. That's less than halfway around that full inside circle. So if it's less than half, it's a minor arc. Here's what you want to notice about this now as well. When we name a minor arc, notice how many letters we use right here. We only use 2 letters to name a minor arc. All right, here's why that is important. If we don't have some sort of way to differentiate there, couldn't we have started at E and worked our way around this circle over to D this way? Couldn't we have gone either direction? So the fact that there's only 2 letters is telling us we wanted the smaller one and we want the blue one instead of the yellow one, okay? Versus when we name a major arc, all right, I'm actually gonna now name this yellow one just so we're clear on this. So I'm still gonna start at E. So when we go to this name, the major arc, we're still gonna start at E. We're still gonna stop at D, just like this one did. But the way we name a major arc is with 3 letters. So if I start at E and I'm gonna finish at D, as long as I pick B, F, or C, it doesn't really matter. Pick any point in between E and D. I'll pick F. Put that in the middle of those 2 letters. Put the arc symbol on top of it. That's the major arc drawn from the point E to D. So when we do this, major arcs, we always use 3 letters to name a major arc. Okay, and the homework tonight, that's going to be kind of a big deal, so make sure we're making notes of that and know those things. Okay. All right, 15. Name 2 semicircles. Semicircles are just halfway around, so let me unshade all of this. All right, so as we look at these here, we want to figure out 2 points that if I start at one and I finish at the other, I get halfway around the circle. All right, so you don't have a lot of options here. So 2 points, if I start at one, go around the circle, end at the other, I'm halfway around the circle. All right. All right. Anybody think they have one of those? Matt? Okay. Pretty good. So if I start at B and I move myself around to C, don't I fill in half of that circle? However, how do I know I went in this direction versus the semicircle below? Couldn't I have done either or? Because those are both exactly half. So the way we need to name semicircles to make sure we know which half we want, the top half in yellow or the bottom half in blue, you also need 3 letters, okay? So Matt said B to C, so I like that. But if we name the bottom half, the blue one, we need to throw the F in between them. So we're going to name that B, F, C. So that would be B, F, C with the arc symbol over the top of it. And then if we wanted to name the yellow half, we again want to start at B, we want to end at C, and you need to pick either E or D, one of the letters that's in between. All right, it doesn't matter which. I'm going to pick the E. So we're going to go B, E, C. B, E, C. That would be the top half of our semicircle. All right, so semicircles also need 3 letters so that we know which direction or which half of the semicircle we are naming. All right. Okay, and then the last thing, stuff that you've seen many, many times. If we want the area of a circle, a little refresher here. This is the area of a circle. Your area is always pi times your radius squared. So if I want that for the larger circle, we go up to the larger circle, find the radius of the larger circle. It is this full length right here. So the radius of the larger one is 11. Plug that in. And the area of the larger circle is 121 pi, 11 squared, and then times your pi. Circumference we should be familiar with. The circumference is the length around our circle. If we want to figure out how many steps you'd have to take to go all the way around the circle, you've seen it 2 different ways probably. It's either twice your radius times pi, but twice your radius is really just your diameter. So you could also just do your diameter times pi. So go to the smaller circle. I kind of like the 2 pi r, so I'm going to go with that definition. We just need the radius of the smaller circle. So if we go to that smaller circle here, clean all of this up, and the smaller circle's radius is, we already said it earlier, is 8. So your circumference is 2 pi times the radius of 8 for a circumference of 16 pi. If I ask you to multiply this out, or we get to a multiple choice idea, just use the pi key on your calculator. There's that key on there. And then if you do, just multiply it all out with 3.14. Okay. Okay. So for homework, I put this on Delta Math. That way, if we're messing this up, we can get it all right. So this will be due tomorrow at the end of second period. So that way, if you have any questions, you have second period to work through it today. You have second period to work through it tomorrow. But it's just, again, it's this here. It says vocabulary of circles. It'll walk you through all these things so that hopefully as we move now throughout this chapter, when we start talking chords, major arcs, minor arcs, a secant line, a tangent line, you're going to get a little bit of practice on all of them. And then we're all squared away with that. So that'll be due ultimately tomorrow at the end of second period. Okay, but that's where you're going to find that homework assignment. All right. Okay,